is have triple bond. So again, the more bonds you have, you'll become shorter because it's like you are having a rope tying to each other. More rope you have means if you have triple bond, you tie to 3 ropes, so you will pull each other nearer. Stronger. So you have single bond, double bond, triple bond, means the strongest bond among the bonds is triple bond. In a question in your test 1, test 2, or final, give an arrangement of sequence based on the bond's strength. So you need to combine A plus B, then you do the E equal to C plus D into equal the equation. Then you use the periodic table for the device bonding. Then you know how much bonding you have. From there, you compare which compound. Okay, so this is just an exercise. So how many bonds electron are in the Levi structures of oxygen? O2, O2. How many bonding electrons? How many bonding electrons? So this steps is quite easy. Yeah? It give you O2 already. O2 means all oxygen. You go to the periodic table in the tutorial, right? So O2, you know, is group number. Electron. Mentioned about 2 rules you must comply to get a stable profile, which is duet, D-U-E-T, which is either valence joined together or octet rules. Duet only apply for the top 2 peak object or element, which is the H and He only. For duet. The rest, you apply octet rule. These 2 are important rules for the rest of the chapter. Because later you need to balance equation, you need to predict the form, and so on and so on. So when the question asks you to explain, you need to include all these things lah. So this one, how many bonding electron? The answer is, I draw on the whiteboard already. How many? 2 or 4? He asks you about what? Electron. He do not ask you bond. He asks you about electron. So the answer is, okay. Answer is 4. So in your test, final exam, you need to give me the Levi structure of the element. So means you look at any question also. First step, you look at periodic table, straight away draw the element and give me the dot presentation of that element. Then only you combine the element. Okay, first step, draw the element with the Levi structures with the dot. Of course, the question will remind you again in the question. Then you combine, right? Then you combine, right? You don't need to show me how you arrange the equation, the dot. I only see the output. Okay, so in the test, some student, you are quite tricky. Yeah, some student, you're not sure. You draw like this and then you put like this. Give me 2 answers. Give me single bond, double bond, and let me choose. I will purposely choose the wrong one. If you let me chance to choose, I will choose the wrong one and give you wrong answer. Those answer that you think is not the correct one, you just cancel with 2 lines. That if 2 lines consider, you don't need to you don't need to do like this. You don't need to color the whole thing black. You don't need. Yeah. Okay. This is just a recap. Now we want to Write the Levi structure for covalent compound. The word compound means the product. Means the product. Right? Means on the right hand side. Okay. So there are certain steps. So for your test 1 and test 2, you need to explain your step, what you do to get the final answer. So if the question asks you, writing Levi structures for certain element, you need to include, the question will be helping you a little bit. You need to include the steps in finding or developing or constructing something. So you need to write all these steps. So there are 4 steps, right? 4 or 5 steps. So first one, you need to write the skeletal structure. What I mean by skeletal structure means you arrange it in without the dot. You arrange the element that it makes sense. For example, H2O. He asks you to draw covalent Levi structure for H2O. The first steps, write the correct skeletal structure. You need to write this sentence. Or the one you need to have the keyword that I highlight in yellow color. So first one, you need to write the correct skeletal structure for the molecule. Then you write H2O, for example. So H2O, you need to arrange. There are few possible. It can be OO2, OH. It can be OHO. It can be HOO. Of course, the first one and second one is same, because if you rotate, the rotation is look like same. This one that I write on the whiteboard is called skeleton. You arrange the element first. Second step, you count the total number of electrons in the structure. Means that you calculate how many electrons for the element. For example, O2, total electron valence is 12. Because for each oxygen is 6 electrons. So the second step, you count the total electron when you combine, become compound. Right. So second step, you don't need to write the whole sentence in the test. You just need to give me step number 2, calculate the total number of electrons. Also can. I'm looking for the keyword on. Okay. Or total number of valence electron. Also can. Okay. Third step, you distribute the electron among the atom, applying the octet or Dewars rules. I'm looking for the third step is to establish or complete the set rules. Or the number 3, you can write chief octet rules, state or duet rules. Also can. Okay, as many as possible means that you try to put in the dot and try to see the in the middle the bonding electron, the bonding bonding pairs. You put in bonding pairs so that you reach octet. Okay. So if any atoms lack of atom, form double or triple bonds if necessary. Means that step number 3, you establish single bond first. You distribute single bond first. You establish the bonding pair first. If not, then you go to step number 4. You increase the bonding from single bond to double bond or triple bond. Okay. Okay, let's look example. If the question asks you to write the Levi structure of CO2, the first step is to build the skeletal structure. So you write step number 1, write correct skeletal structure, or you can just write the skeletal structure. So CO2 you arrange like a Lego, you write CO2. So I just straight away give you the combination. So CO2 normally the compound, the individual one, it will in the center. Because C is 1, oxygen is 2. So normally the one that individual one, it will in the center. So this is called skeletal structure. So you arrange OCO for the first steps. So get 1 mark for this one. 1 mark with the skeletal structure in your answer. Okay, second one, calculate the total number of electrons. So based on periodic table, you know oxygen have 6, carbon is very popular element in this module. Carbon is 4, group number 4. So again, oxygen, hydrogen, carbon is a very popular element in this module. You will see it in chapter 1 until chapter 8. So when you see the question mention carbon, oxygen, you must know what group it is already. Okay, it's like gravity, 9.81 in physics. Okay, so from this one, you know, 6 plus 4, 10 plus another 6 is got 16, right? So this is just show you how to do it. In the exam, you don't need to show me the periodic table, but these are just the steps. So again, you need to write this equation in your answer. You need to write total number of electrons equal bracket valence electron for carbon plus 2 bracket number valence E negative for O. Right, this is expected in your answer. You need to give me a mathematical model, right, or equation. So in the test, like what I briefed you in the previous class, the structure of the question will be 3 ways of asking you. First will be definition. I'll ask you about the definition. Second one, I'll ask you about the equation or analysis method. You need to count something, then you need. The third part of the question will be, now, what is that number means to you? Or explain why that number means something, right? A reason. So here, then the next step, you just fill in the simple mathematics. Here in chemistry, there is no integration, there's no calculus. It's all multiplication and addition. And maybe sometimes it's just exponential 2 or 3. So you do the calculation, then you get 16. Okay. So you need to explain your answers in test 1, test 2, and final exam. So step number 2, calculate the total numbers of electron valence of electrons. Then you give me this equation, total electron equal bracket C plus bracket 2O, something like that. Then you give me the numbers. So step number 2, full set, 1 mark. Because it's too simple already. So I will give you 1 mark. Unless you have involved a lot of calculation. Okay, step number 3. Okay, step number 3. Yeah, so this one you draw this one you draw the element in the answer. Step number 3. So by step number 2, I expect you to draw Levi structure for the element already. In the answer, I was looking for these 2. Number 3, you distribute to apply or to comply octet or Joule's rules. Joule's rule only apply for helium and hydrogen, which is the top 2 element in the periodic table. In this case, you don't have helium and hydrogen, so skip the dual rules. Straight away go to octet rules. So these steps is you try to combine. So you start with the middle one. C got 4 octet, 4 valence. So you form single bond first. You share. You got OO. It depends on how you combine. So you work with the carbon first. Work with carbon. Bonding electron. So C double bond, double electron valence. You write O. You don't need to. This is just your steps. I only look for the final. It's just a perfect. So O double dot C double dot O. Okay. So you total, you have 16 just now. You have used 4. Right? Because carbon has 4, so you use up all the 4 first. Then 4, the balance 12, back to the side. the two members at the side. So is you got 6 at the 6 at the side, right? So proceed to lone pairs. Lone pair means just now got the do not have the pairs. So here you work with the four. Right, can all right, so we move to step number 4. So step 3, what I want to see is this one, this diagram. Okay. Step number 4, you need to form double or triple bond if it is not yet balanced. So in this case, does it balance? Does the atom balance? Does it apply octet or dual rules? Carbon, does a carbon balance? No, right? So how you balance it? You can shift lah, shift the electron. Oxygen already stable. Oxygen already stable because oxygen already have 8. Carbon don't have 8, so you need to find, you need to shift around the electron so that carbon have 8. Okay, so you shift around. Okay, you shift around. If you move one electron from oxygen, also not balanced, because if you shift one from left, one from right, carbon only have 6, do not meet the octet. You need to shift another one to the middle so that it reach octet. So that, like the diagram you see on the screen, you move the pair, it will form something like that. So you need to shift play around with the dot, make sure it apply the octet or those rules. Okay, step number 3, you need to give me this diagram. Then step number 4, you need to balance the things. So at the end, I'm looking for this answer. This answer that oxygen, you have 8 electron, carbon, you have 8 electron, oxygen, you have 8 electron. Okay, then convert the dot into line. Into line means change into Levi structure with bonding. Okay, you need to simplify the Levi's diagram. So edit out. Okay, so here you have your form double bond. This is called double bond. Double bond on the left, double bond on the right of the carbon. Right. Now CLL2, carbon chloride, CCl2, the same procedure are you able to do? Write the Levi structures, how you at the end you reach you can see the bonding, the double bond, single bond, double bond, triple bond. So first step is to write the skeletal. So same, you repeat the same steps. So write the skeletal structure. So you move the element together. So you have three elements there. It is carbon, chlorine, chlorine. Right? So you arrange, and again, just a rules of thumb, if you have an individual element, usually in the middle. Okay, so this structure will look similar like the example just now. So carbon, you know, is 4. Cl, group number. Cl also another popular element you will see in later chapter. Cl will be group number 7. So got 7 7 electrons. So you group the skeletal first. Sorry, this one is wrong one. It should be Cl. It should be Cl4, right? Cl3, yeah. Oh, okay. So my slide is wrong. It should be Cl4, right? Yeah. Okay, so typo error in my slides. It should be CCl4 as what you see in your tutorial question. CCl4, it should be have 4 chlorine element. So first step, write skeletal structure. You group based on the Lego principle. You group them together. Calculate the total number of electrons. So carbon, you know, is having 4. Chlorine is group 7, so you have 7 electrons. So you need to give me the equation, the simple linear equation. Right, so you write total number of electron equal bracket number of electron of C plus 4 bracket number of electron Cl. Then the second step, you go to second step of the mathematics model, we go and substitute the numbers. And okay, so 4 plus 4 multiplied 7 is 8 plus 4, you get 3. And this is the illustration, how you get it. Again, always draw the element with the dot in part of your answer, just to remind yourself. Because sometimes when you know, in test or sometimes in exam, your mind will do something else. Although you in the table, you know that it's 7. Sometimes in your calculation, 7 will become 5, some will become 6. So this is just a reminder when you check. Okay. Again, give the equation. The final answer is 2. Step number 2, we have done. So go to step number 3. Step number 3 is the distribution of electron. So you apply or to comply the octet or Dewars rules. So you start with the middle one. So carbon have 4. So you start with the 4 in the middle, and then you pull 4, you start to minus 32 minus 4, that's 28, divided by 7, like that. So this is just your scratch at the behind the screen. So we start with the bonding electron first. So here you start with the middle element, right? Carbon got 4, you pull another 4 electron to reach octet. So the first stretching or your answer will be C and then 8 electron for the carbon. So 32 minus 8 will be 24. Right? So you distribute the rest of 24 for the 4 Cl element. Right? So this is the answer for the next steps. So you do the 8 electron in the middle first. So 32 minus 8, you have 24. 24 divided by 4, you have 6. So you put in the 6 dot for each of the Cl. Then you check whether it reached octet or not. You check Cl as carbon in the middle first. Carbon 8 electron octet achieved. Then you check for each of the Cl. So Cl on the left, you got 8 electron octet. On the top, 8 electron octet. On the right, Cl, you got 8 electron octet. And bottom one, Cl, you got 8. So this one already balanced. Next, you convert the dot, the bonding bond into lines. Chain into lines, right? So one line represents 2 dots. Okay. Okay. So, like for example, this example, C and Cl with 6 lone pair. Okay, my next question is just a simple mathematics. Can you count number of bonding pair and number of lone pairs. How many bonding pair for CCl4? How many bonding pair? 4. Means you count the dash, the line. Okay, got 4 bonding pair. How many lone pair? How many? How many? Lone pair. This one become 2 outside one. You count as 1. So got how many? One element got 3, right? So you got 4. So you have 12 lone pair. Okay. For example, okay. So this information is important for the later section where you need to predict the shape of the compound. Okay. So for this example, again, there's a typo error. It's not Cl2, it's CCl4. That's what you see. Okay, this is just your homework. Go and see whether you're able to build the Levi structure for H2, CO2, and CO. This one, if we have time, we'll come back to this. If not, then you do it as your homework. Okay. All right. So, any questions so far? Yeah. Right. So, next, just now is covalent compound. Covalent compound is non-metal plus non-metal. Again, ionic compound is metal plus non-metal. Okay. So again, how you know it's metal and non-metal? In the periodic table that with colors, you'll know. In the periodic table I give you in your tutorial, you'll know which one is metal, which one is non-metal. So now we go for polyatomic ions. We need to apply the same scale for by drawing Levi structure for ion. Ion means it fall under ionic bonding. With this, ion means you have an extra charge or negative charge. Means you are dealing with charges. So if you see it in a question, you see ion, it means you need to use the bracket already. Bracket something element inside, and then the charges. If positive charge, you put positive charge. If negative charge, you put negative charge. Okay. In chemistry 1, how last lecture also we also have 2 names for positive charge, negative charge. Positive charge is called cation. Positive charge. Negative charge is called anion. Okay. So same, so this one you read, whatever you can read, I'll just skip. All right. So here, okay, so this one is if you talk about ions, you need to pay attention to the charges of ion. All right. So charges of ion, what does the green color means? Just now, okay, let's say I put CCl4 just now. This is stable, right? So if this one changed to ion, if the question asks you to find CCl4 negative charge, in second steps, when you calculate the total electron valence, if it's a negative charge, you need to add 1 more electron in the calculation. Okay, so CCl4 in second step just now, total electron is how many? 32, right? Right? If the question asks you to build the Levi structure for CCl4 negative, in step number 2, you need to add the total electron is, okay, total electron equation just now, total electron equal C electron plus 4 Cl electron. You need to, at the last steps, what I'm looking for is you need to plus 1 electron like that. If it's negative. If it's positive, CCl4 positive. What does it mean? How a compound become positive charge means it let go electron, throw away electron, because the inside positive charge cannot change. So what you do, if it's positive charge, in the second steps, you need to minus 1 electron, for example. This is what the green color means. It just change your second steps. If you involve, the question asks you about ion. This will be the question that I love to ask, this kind of question, because I can see careless mistake from here. And some of you will forget to plus or minus electron in the steps. Okay, so just pay attention. This ion and ion one. Okay, so here it just a highlight. I did explain on the whiteboard just now. So is there any symbol we use for procedures? Yes, we use bracket to represent. So for example, okay, this is this red color one is the final answer. It's just a final answer. You need to use the bracket to represent. So let's repeat the same procedure for Cn minus ion. So Cn minus ion, still the same. First steps, you go to periodic table, find carbon, where is group 4. So you pull the element out, draw the element C, and then 4 dot. Nitrogen and group number, I cannot remember. Nitrogen is group 6 or group something. 5. Okay, group 5. So you draw nitrogen with 5 dot. Just to remind you when come to step number 2 . So step 1, again, write skeletal structure, means you group it. So in this case, there are only 2 elements, so it doesn't matter. You just write C and N. So again, skeletal structure, I expect you to write the element only without the dot. Okay, so if you write skeletal structure but without writing this one, but you skip to step number 2 and give me dot, there's no marks for this one. I'm looking for the answer. You need to show me how you do the skeletal structure. Okay, step number 2, you calculate total number of electron valence. So this is ion. So in this step, you need to give me extra lines for the ion, which is if positive charge, remove 1 electron, remove electron, positive charge. You need to write this one, this statement. You need to write the green color statement. Just add to the second steps. Add 1 electron for each negative charge and subtract 1 electron for each positive charge. Okay, if you're fast enough, you just apply one of the line to that question. If you don't know, you just memorize and then you write this one in the steps. Okay, since this is a negative, so you add 1 more electron. You add 1 more negative charge because it's negative charge. Okay. So here, you know that carbon, nitrogen, group 4 and group 5. So this is how you write the answer. Total electron equal number of valence E in carbon plus number of valence in nitrogen. And what I want to see is the plus or negative at the back of the equation. Okay, you don't need to write the blue color marking. I only want to see whether you understand how to count the total number for ion. Okay, right. So put a remark also. In test, I won't give you simple ion. I'll give you 2 positive or 3 negative, something like that. So just I want to see whether you know how to apply the equation. So here you'll get the total number of electron is 10. So when I mark until this step, I already know whether you can score for the next mark already. If I do not see 10 in the answer, means step number 3, number 4 is wrong already. And the Levi structure confirmed wrong already. So I don't need to mark already. Okay. So for this kind of question, Levi structures is normally 4 marks, 3 to 4 marks for each steps. Okay, the rest distribute. I just show you the thing. So you start with, normally you start with carbon. Start with carbon. So carbon you build with a single bond first. So you use up 2. Then you go to the nitrogen, got 5. Right? You distribute carbon with 2 dot here. And then nitrogen got 5. CN2, CN. Looks weird to me. Okay, correct. Because the total number is 10, it's not the normal stable compound. Because this is negative charge, so it's 10. So you got 10 electron. So you build the carbon bond first. You take 2, then valence is 8. You divide the 8 into the molecule. But this is not stable. As you can see, it's not stable. Right? So you need to stable it by applying the octet or dual rules. So how you do? You need to rearrange the atom so that each one of it got 8 or sharing 8 electron. Okay. So we can pull the 2, right? So you can pull the 2 to the middle. It become triple bond. Remember, this is ion question. The final answer, we are expecting you to use the bracket plus the negative or positive signs at the top of the right corner. Okay, change the dot into lines bonding. Yeah, so this is quite simple lah. Right, so the rest you read. This is just a check. This is just a check, a quick check. In exam, you won't see ABCD because you are taking the foundation already. So normally there will be no ABCD. So how many electrons are there in Levi structures of OH negative? Just count. This is step number 2 question. So by hand or by periodic table, you're able to guess. How many electron valence? We refer to periodic table. Sasru? Sasru, how many electron valence? How many electron in OH negative ion? Which Sharil? Sharil, right? Okay. Sharil, how many electron oxygen have? How many electron valence oxygen have? Oxygen group number? 6. Got how many? If it's 6, how many electron outside? How many? I already draw in the whiteboard here already. If it's group number 6, how many? Group number 6 got how many? Huh? You count, right? Quorum, right? Group 1 got 1, group 2 got 2, got 3 got 3. So group 6 got how many? 6. Oxygen got 6. Hydrogen got how many? Group number 1. So got 1 electron. So 6 plus 1, 7 plus this is ion. You need to add or plus. Need to add electron or remove electron. Add electron. So total how many? 6 plus 1 plus 1 is 8. Huh? Okay, so this is how you calculate lah. Huh? So I just give you the steps just to do lah. Huh? All right, so if you this is the step to establish it, but this I think is more than the question. So it's 8, then you should able to draw the ion, right? So I just do lah for you. This is just a additional answer to apply the 4 steps, right? So yes, yeah. Okay, so this is the thing, right? Okay. Okay, we stop at this example. We come back 12:05. Is that okay? 10 minutes breaks. Yeah, 12:05.